All right, so we'll have a look at an example in the textbook. This is on page 280. Example 5. So at a coach station, the maximum temperature in degrees Celsius and the number of bottles of water sold were recorded over 10 consecutive days. Collected data is summarized in the table. So first of all, we plot the data points on a scatter diagram. And since we have the calculator to help us here, that's what we're going to use. So we go into the Stat menu. We can delete whatever is here, or we can just write over it. That amounts to the same thing. So we put our axis in here. Just check that you have 10 values. Between I don't know. I mean, you have 10 points, right? So 10 x values. I'm just putting in the points as they are written. Yeah. Okay. So once you have all the data put in, we can graph this on a scatter diagram. So it's going to look like this. Okay, so first off, we comment on the correlation. Well, we can certainly see that there's a clear direction to the data here. Now, without the calculator, it's difficult to say anything about the strength of the correlation other than that it looks fairly strong. The next question is to find the equation of the regression line of y on x. Right, so I yeah. Graph, okay. So I click F1 for calculate, X for linear regression. And I get these values up here, but I want to draw the line as well, so I'm going to click draw. So this is what it's going to look like. Now, if I go back here and click F2 for X, I can see the different calculations that are made for this. Just going to change the view here so I can see both what I'm writing and the calculator at the same time. Let's see. Ow. Let's try something like this. Yeah. Okay. So this is example 5, page 280. Okay. A regression line is a straight line, so it's going to be on the form y equals ax plus b. And these coefficients, these numbers A and B, are calculated for us. So A is equal to 8.046 more or less, and B is equal to minus 24.75. So this is going to be the equation for my regression line then. Y equals 8.046x minus 24.75. Right? So this is our equation for the regression line. Now we can also comment on the strength of the correlation. And we can do that by looking at the R value. So the value of R is 0.93. R squared is 0.87. So this means that this model, this correlation line, explains 87% of the variation between the two variables. The R value is quite strong. It's 0.93, so fairly close to 1. It's stronger than 0.9. So the closer you get to 1 or minus 1, the stronger the correlation. The closer you get to 0, the weaker the correlation is. Right, so look at the final question here. The temperature is predicted to be 19.5 degrees. Estimate how many bottles of water should be stocked according to this regression line. So if we have our regression line drawn like this in a scatter plot, we can press Shift and Gsolve to do a Y calculation. And we want to do a Y calculation because we want the number of bottles that we can expect to be sold. So that's how many bottles of water should be stocked. And if we press YCal, we are asked for a X value. We can put that in, 19.5. So if the temperature is 19.5 degrees, we can expect to sell 132 bottles. Expect to sell 132 bottles. I mean, yeah. I'm not going to say exactly how many should be stocked, but that's the expectation for sales anyway.